Well, hello friends and followers. What do we have here? Again, the 100V transmitter by Central Electronics. So I've been battling with this thing all day. I can't say this is probably a smart way to spend my life, because I'm not making much progress. I spent all day on the power supply trying to decrease the voltage. When this thing is brought up to line current at about 125 volts, I get about 845 volts on the B+. That's supposed to be 600 volts for the finals, and the supply for the B+ for the regular small tubes is about 435 volts. So let me show you what I mean. Right now I'm running it on the Variac down here. I think I'm throwing about 90 volts into this thing. The line voltage here is low. If you look at the line voltage, and let's turn it around here for you. If you look at the line voltage, it's around 90 volts. I think when it touches the scale there on the top, it's 100 volts. So that seems accurate. Anyway, so beyond all that, let's take a look at the voltage readings on the B+ here. Oh, actually, let me show you something else here. So I've been trying to get it running basically in its crippled state, and I'm looking at the bias supply here for the final tubes, and we're seeing about minus 103 volts. My bias supply is low just because my power supply is all in disarray. But anyway, I have to work with what I have to work with. I tried changing the power supply today all around to even a different transformer, which I ran outside the unit. I was trying to get the Tektronix transformer to work. I had to series together 3 secondaries and get 600 volts out, but it was a disaster. So I just wired it up the way I had it, which is a 200V power supply configuration. Anyway, with that said, I just want to now get it to work. So I couldn't get the finals to bias correctly. There is no bias control in this thing for the finals, at least not in the 100V. So you have to kind of muck around with that resistor, and you can see the one that I changed there. That's now a 2K resistor. There was a 1K in there, and the way it works is you'll see there's minus 103 volts in there now. But when I key the transmitter up, you'll see that'll go to 0. The relay closes that. So they have a voltage divider which is consisting of this resistor first, and then they have 2 more of them in line. The finals basically get their bias between these 2 resistors, and that goes to the final via a choke, the finals. Anyway, to make this work right, and I'm sure it's not really right, but to make it work satisfactorily, I put a 2K resistor in there and took out the 1K. And that gives me sort of a reasonable rendition now. And let me show you what I mean. So, excuse me turning over the camera, but the unit's upside down. So now if I am on, say, I think I'm on AM now. I'm on CW. So since I'm on CW, I can turn the CW carrier all the way down counterclockwise. I can turn down the power counterclockwise. And then when I run this thing up to transmit, you want to watch the meter then for the watts. So we'll go to watts. No watts right now. We're not transmitting. And that's basically watts consumption. It's not watts of output. That's watts fed into the final. And so now you'll see it's chomping about 120 watts, and that's idling. It's not really doing anything. So that's setting the bias to make the tubes go. Drake doesn't really have this, so you don't know what kind of watts a Drake is chomping, but that's how this guy works. So with no signal at all, it's chomping about that much. I did try to increase the value of this resistor so that it wouldn't pull the bias down as far. It's probably going down to minus 40 volts now. I tried like minus 45 volt bias to make it run easier, and the meter did go down. And if you actually disconnect that resistor right there, the finals won't work at all because they're on cutoff bias, and the meter will not show any watts consumed at all. So I was trying to balance it between not so many watts consumed and to have decent power out. So on, say then, keying it on CW, there's no drive at all. I'm keyed. I'll increase the power output to half. Boy, this camera. Increase the power output to half here. And with the CW drive down, there's no change. If I turn the power output up and down all the way, there's no change. I'll leave it at half. So now we're at power output of half. And now I can change the CW knob here, and you'll see that the consumption will go up. So there's 200 watts consumption input right there, considering the bias plus the RF. And you'll see the power will move up and down accordingly. I can get about 100 watts out of this thing, which is what's rated for. Barely. So that's, I guess, decent. And if I go full power, the meter pins past 200 input. I'm not sure if this is reasonable or not, but that's what I have right now. So I guess I'm going to leave it the way it is. If I unkey and I go to AM mode here, okay, there's AM right there, and I key it back up, and I increase the AM carrier here a bit. You'll see it'll start spiking up with AM. And there's the power input. This doesn't change. And when you add carrier, of course, it goes up, much like CW. So that's my little demo here. Unfortunately, I'm still running on the Variac. I can't seem to get the power levels right on this thing. Let me show you what I mean about the power supply. So let me unkey there, and let's get this meter unplugged from that bias there reading and not shock something, and let me ground the meter. It's grounded. Okay, so now we're ready for measuring. So let's show you the B+. So first of all, I'm upside down. There we go. So the high B+ is, you can find those on the bachelor coils here. So you can just touch a bachelor coil and it will show you B+. So I'm running over at 776 B+ right now, which, you know, power supply is all screwed up. Transformer puts out about 870 volts AC when I'm on 125 volts line. So I can't figure out what to do with that. I have no idea how to fix that. I guess I'll just use it the way it is with the Variac. And you can find the B+ right here. The small, this is supposed to be 340 volts right here, which is the small B+ for the regular tubes, and that's running at about 460. That's supposed to be 340. My capacitors will crap out at around 450, so that's right at the edge. I probably should take the Variac down a little bit. And you'll see this will climb down. That's probably within tolerance of my capacitors. This will climb down. Let's see the bachelor voltage here, the B+. That'll climb down. Whoops, that has nothing now. Why is there nothing? That's weird. How can I lose B+ like that? That's really weird. Just lost all my B+. I don't know, people. I got some problems in this thing, don't I? What if I raise it up again a little bit? I got voltage again. That shouldn't go like that. So I got some power supply problems. There's no way it's going to go to 0. Okay, now it's working. Lower it a bit more. Probably the meter wasn't making contact. That's about reasonable. And what's our B plus now? 402. Now, will the radio still go at these levels? Let's see. Can I still transmit at these levels? No signal. Do I have drive? Let's go to full output. Full AM. Yeah, I can transmit. It's not as strong as it was, but full AM. Power control on full. Let's hike up the voltage a bit on the variac. Doesn't really change it a whole lot. Hard to say. I am on AM now. Power control's up all the way. I'm not sure why there's a variability. Can't say I know. Anyway, that's my video. What can I say? Fixing these boat anchors is laborious. It's time consuming. It's kind of fun, but when you don't make much progress, you kind of wonder what you're doing. And that's kind of where I'm at with this one. This is probably the hardest radio I've ever tried to fix. It's the most complex. It's been the most fun in many ways, and it's the most rewarding, but I've probably burned 3 weeks of time on this thing now, on and off, fixing the power supply, and I still can't get the power supply working. I converted this thing to a 200V power supply as best I could, but the power supply voltage, as you can see, is too high. All right, that's my demo. I still want to replace the capacitors in the balance, not capacitors, the diodes in the balance modulator with Schottky, RF diodes. I still can't do a decent null on this thing. In fact, I can show you the null. If you go to null mode here, it will attempt to null. It's spring-loaded. So you can see I'm fairly nulled there. It's hard to hold this. Let's see, let me go the other way here. There we go. Since the radio is upside down on my desk, I'm gonna turn the camera upside down. Okay, so when I turn these little null controls here, you wanna go for 0. So this one works. As you can see, it nulls. The other one does not. I can turn it one way and it will null, as you can see, but it doesn't do a whole lot. And I'm having trouble holding this knob. Yeah, this one doesn't really do a whole lot for nulling. The other one nulls, so that's probably why my sideband doesn't work and why I'm stuck with double sideband for now, but I do have some pretty good carrier suppression. All right, that's my demo. I can probably use this rig pretty soon the way it is, but I don't like the power supply being all ramshackle. It's frustrating. All right, if I could find a 200V, I guess I would know more about how to fix it. I may never figure this one out unless I spend a lot more time on it, and I'm not sure I'm going to do that. Well, thanks for watching. Have a great day, and if you have a 100V from Central Electronics, I hope you enjoy it, and good luck fixing the darn thing. Bye-bye.